Evolve has been installing and operating critical infrastructure since 2004. They've deployed over 5,300 megawatts of backup power. They've built hundreds of square feet of data center space. They hold several patents in the data center space, and they operate both domestically and internationally. So the incumbent pressure letdown process is really not so complicated or difficult. A compressor station somewhere upstream in the pipeline increases the gas pressure so that the gas can move from upstream to the downstream end user. A Joule-Thomson valve, or a pressure regulating valve, is used to reduce the pressure of the natural gas to the end user's requirement. But these valves have no way to recover any of the energy which has been input at the compressor station. So turbo expanders can be used to recover this lost pressure energy. Sapphire's designed a system which we think minimizes maintenance costs, operating costs, and capital costs for the operator. With so much natural gas moving across American pipelines, there's a significant amount of pressure energy which can be recovered in these U.S. pressure letdown stations. And to understand how much, we need to look at a few different data sets. We need to know how much natural gas is being consumed in the country. We need to know where that gas is being consumed. And we need to know what the average pressure looks like, both upstream and at the end user. So if we do this, we're able to understand what the enthalpy difference is, both upstream and downstream. And we can use it to determine the isentropic power potential of the entire U.S. natural gas network. So in other words, we can understand how much energy is available for recovering the turbo expanders overall. And so we're looking at that on the right-hand side here. We're estimating that about 3 gigawatts of power is available for recovering in turbo expanders at varying parts throughout the natural gas network. So an existing pressure letdown station may look something like this. A heat exchanger may be integrated upstream of the regulating valves in order to preheat the gas before expansion. Here you see a couple of Joule-Thomson valves, pressure regulating valves in parallel to each other. So a turbo expander can be integrated in or on a bypass line to these existing Joule-Thomson valves. During operation of flow control valve, we're showing right here, is used to split flow between the Joule-Thomson valve and the turbo expander. The gas that's moving through the turbo expander on the bypass line is used to generate clean electricity in the expander. So Sapphire has a product in the market. It's called FreeSpin. We call it FIT for short. It works in the following way. So high pressure gas is entering the expander on the inlet side. It's being directed via a nozzle into the expander wheel here. And the wheel is directly coupled to a permanent magnet generator. So gas is going through the wheel spinning, the generator, which is directly coupled is spinning, and a voltage is developed in the stator. We pull the current out of the system, we direct it to our power electronics unit, which we call our variable speed drive. The power is being conditioned there to a usable frequency and voltage, and the end user is using it to power the load. There are a few novel technologies we've integrated into our system. First, we operate on active magnetic bearings. So during operation, the mag bearings levitate the shaft. There's no friction between the moving components. It enables very long design life in our rotating equipment. Our patented flow-through design allows for expanded gas, which is cooled during expansion, to be directly passed over the rotor and the stator, providing heat exchange. So there's no need to introduce any kind of external coolant into the housing. Likewise, there's no penetration for lubrication on the mag bearing, so the whole housing is hermetically sealed. It's easy to integrate into the pipeline. There's a flange connection on the inlet, a flange connection on the outlet. Overall, the system's compact as well. It's about 4 foot in length and about 2 foot in diameter. So I'm going to have John come up. He'll talk about integration into a broader system, right, and how the power can be used.
Hello everyone, thanks for showing up. It's late in the afternoon. There's maybe better things to do than listen to us, but my experience is with turbo machinery. Even though I'm working at a data center type of company, they have a lot of power generation for backup. There was a need for larger and larger generation requirements, so I was brought on to help with some of these larger type of products, and this is one of them that we are working on. As you know, pipelines are all over the country. They're quite remote in most places. They don't go right through major cities. And the pressure letdown stations are also relatively remote when they come to a city gate. Because of that, there aren't things like a grid to connect up to. Even if there was a grid relatively close, there's still a lot of money in getting the transformers, all of the infrastructure set up, and it becomes cost prohibitive. And for the most part, that's why this hasn't been done. Expanding gas and getting energy out of it, that's a known technology, but it hasn't been economically feasible for quite some time. It also is difficult to get connection to the grid. It might take a year or more to be able to get an interconnect, and it's time wasted when you're trying to make money. In addition, if you put generation at a pressure reduction station, you don't need the power there either, so there's no consumer at that location. What we do know is that you're really going to have to put a load at that pressure reducing site to use the power that we can generate. That load needs to make a good revenue. Someone needs to want it. There needs to be a service for it. Generally, it's going to need to be modular, easy to set up, quick, and we believe that a data center is that key to making this a feasible product. What Evolve is going to bring is modularizing these turbo expanders from Sapphire. What you see here is our package. We simply put 4 of them together on a skid. Most of the scenarios that we looked at when we see the flow rates of these larger scale city gate power station or pressure reducer stations, they could supply enough gas for 4 of these units. Jeff didn't make a note, but each one of these is roughly 300 kW of power. We put 4 of them together, we get a 1.2 max output. As you can see, everything's installed, control valves, isolation valves, all the instruments, all the wiring is done, so you can just set it on the ground. We can leak check it ahead of time. It's designed to the API standards, the ANSI B31.8 for pipeline spec piping. It meets the Class 1 DID 2 for the flammable gas. You just put it on concrete pylons and hook it up to the pipe.